The Committee on Science, Space, and Technology will come to order. Without objection, the Chair is authorized to declare recesses of the committee at any time. Good morning and welcome to today's hearing entitled SBIR, STTR Reauthorization and Review of Technology Transfer. I now recognize myself for 5 minutes for an opening statement. The foundation of America's future economic success is and will continue to be our global leadership in science and technology. Taxpayer-funded basic research conducted through the National Science Foundation, NASA, NIH, DoD, and other federal agencies underwrite the breakthrough science and the key discoveries that have created today's world: the internet, wireless communications, life-saving medicines, lasers, artificial intelligence, and so much more. Converting scientific breakthroughs into innovations creates new industries, new businesses, and new jobs. Such innovation transforms commerce, everyday life, and our entire society. Risk-taking entrepreneurs and small businesses are the catalysts for these innovations. They are the catalyst for economic growth, for generating the family and community-sustaining jobs that we need so badly. Congress enacted the Small Business Innovation Research, or SBIR, program in 1982, followed by the Small Business Technology Transfer, or STTR, program in 1992. These two programs accelerate technological innovation and commercialization of new products and services by small businesses. They also help the Department of Defense and other federal agencies meet their research and development needs. Federal agencies with large extramural research budgets, more than $100 million a year for the SBIR program and $1 billion for STTR, award competitive grants to small businesses for technology development and commercialization. 11 agencies hit the $100 million research budget threshold for SBIR. They're required to set aside 3% of their extramural research budgets to support SBIR, and that will rise to 3.2% in FY17. 5 agencies, including NSF, NASA, and DOE, surpassed the $1 billion threshold for STTR. These 5 agencies also account for about 98% of SBIR. These 5 agencies are required to set aside 0.45% of their extramural research budgets for STTR grants. Since its inception, participating federal agencies have awarded SBIR and STTR contracts and grants to small businesses totaling more than $40 billion. A number of companies that use SBIR are located in my congressional district, and I hear often about people who are both working in this program, have issues on how it can better be utilized, and so I really do look forward to that discussion. Just some of the companies I know in my district are 3 Phoenix Inc., Aurora Flight Sciences in Manassas, and Mosaic ATM in Leesburg. Progeny Systems of Manassas, Virginia also in there, and there are a number of others. I do look forward to hearing from our panel of expert witnesses this morning, including individuals who lead the administration and management of 3 of the largest SBIR and STTR programs, and the Vice President of Research from one of our nation's most prominent academic research universities. I now recognize the ranking member, the gentleman from Illinois, Mr. Lipinski, for his opening statement.
Thank you, Chairwoman Comstock, for holding this hearing to review the SBIR and STTR programs, as well as to examine national efforts to support commercialization of federally funded research and development. Those of you who follow this committee know that I'm always focused on finding better ways to promote commercialization of research, especially the great research funded by the American taxpayers at our universities and national labs. This hearing is an important step in the reauthorization of the SBIR and STTR commercialization programs, which our subcommittee has jurisdiction over. In the U.S., where small businesses create 55% of all jobs, the success of the small business enterprise is key to economic growth. For almost 40 years, the SBIR program has been funding small business innovation across all sectors of our economy. There are many prominent success stories from SBIR grants. A recent Air Force review of Phase 2 winners between 2000 and 2013 found that 58% of them had sales in excess of $1 million. Importantly, many of the innovators who create these small businesses are educated and trained in our nation's great research institutions with support from federal research dollars. And some even directly commercialize research funded by federal dollars. The federal R&D enterprise is truly an ecosystem from basic research to commercialization. Unlike any other program that I'm aware of, SBIR and STTR are funded using a percentage of participating agencies' extramural research and development budgets. That percentage has increased by 30% since 2011, even as the larger budgets have remained flat. While the SBIR program has great value, we must look at it in the context of overall agency budgets and missions. Increasing the set-aside for SBIR and STTR as much as has been proposed by some could come at the expense of support for other critical research programs. Perhaps my biggest concern is harm done to the pipeline of STEM talent and innovators by increasingly lower research funding levels. This is a difficult choice in tough budget times because both research and commercialization activities are highly valuable investments. We must also look hard at assessments of the SBIR program and consider ways to make it more efficient and help the program better achieve its goals. And this hearing is a good opportunity to talk about other ways to improve the commercialization of federally funded research, including the very successful Innovation Corps program started at NSF in 2011 and now expanding to other agencies, as well as the NIH's Proof of Concept pilot program. I-Corps is essentially an entrepreneurial education program. The I-Corps Node program provides this education and other support for innovators at our research universities, creating a true interconnected national innovation network. I'm pleased that Ms. Garton is joining us today, and I look forward to her testimony regarding Georgia Tech's I-Corps Node program and the challenges innovators face in seeking early-stage funding. In the 5 years since the I-Corps program has been running, it has clearly demonstrated its value in improving tech transfer and commercialization. And we are beginning to see that it makes the SBIR program more efficient as well. Although it takes time to fully realize success in commercialization, the early returns show I-Corps trained teams having more success than comparable teams without this training. I think the time has come to talk about having some kind of I-Corps program at every agency with an SBIR program, as the two truly go hand in hand. Finally, I want to mention language that I put in the 2011 SBIR reauthorization bill, which allowed for an NIH proof of concept pilot program, utilizing a small portion of the funds from the STTR set-aside to give grants to researchers at pre-SBIR stage. This could be called SBIR stage phase 0. Many university researchers are hesitant to start a company, which often means leaving their university. So they're hesitant without having confidence that the idea can work out. The proof of concept pilot has led to programs at NIH, such as the NIH Centers for Accelerated Innovations and the Research Evaluation and Commercialization Hubs, or REACH programs. I believe programs like these can be an important part of the innovation ecosystem, and I look forward to an update on the pilot from Dr. Lauer. I know the agencies here today are exploring many other aspects of early-stage commercialization, including how to coordinate these efforts better with the SBIR program. I look forward to this broader discussion about commercializing federally funded research. I also look forward to your testimony about how you've implemented new requirements and flexibilities in the SBIR program since the 2011 reauthorization, and what our community should consider as we take up the next reauthorization. I'd like to ask unanimous consent to enter into the record the administration's principles for SBIR, STTR reauthorization, and the letter dated May 10, 2016 from a coalition of science organizations and universities.
Thank you, Ms.
Can I get unanimous consent on
Yes,
to
without
put those in the
objection.
record. Thank you. And with that, I will yield back. Thank you.
Thank you, Mr. Lipinski. And I now recognize the chairman of the full committee, Mr. Smith.
Thank you, Madam Chairwoman, and I appreciate both your comments and the comments by the ranking member. The Small Business Innovation Research Act, or SBIR, was signed into law by President Reagan in 1982 to help spur innovation and increase small business participation in federal research and development activity. Since then, more than 100,000 small businesses in the United States have received SBIR grants to convert taxpayer-supported basic research discoveries into commercial technological innovation. The Small Business Technology Transfer Program, or STTR, was approved by Congress in 1992. Its unique feature is its requirement for a small business to collaborate with a nonprofit research institution in order to bridge the gap between basic science and commercialization of resulting innovations. Both SBIR and STTR are funded through a tax on federal agencies' research budgets. The SBIR tax on research began at 0.2%. That tax is now 3%, or 15 times higher. 12 federal agencies, those with annual external research budgets of $100 million or more, are currently subject to the SBIR tax. The 5 federal departments and agencies with annual external research budgets of more than $1 billion are also taxed to provide funding for the STTR program. That tax is an additional 0.45% of the 3 research agencies represented here today, DOE, NSF, and NIH. These basic research taxes currently amount to approximately $2.5 billion each year for commercialization grants to small businesses. Grant recipients run the gamut. Although about 1/4 of the companies are first-time recipients, most participating small businesses have received multiple SBIR grants. Some former recipients of SBIR assistance have even become very large international corporations, such as Qualcomm, Sonicare, and Symantec. SBIR and STTR companies have created parts for NASA's Mars rover, equipped our military men and women with key warfighting innovations, and generated a long list of life-saving medicines and healthcare treatments. SBIR and STTR recipients have thousands of new patents and created thousands of new jobs, many in new areas of technology. In the leading-edge field of nanoscience, we're learning that tiny particles can have very big effects. SBIR support enabled Applied Nanotech of Austin, Texas, to become a world leader in nanotech breakthroughs, inventing cheaper, more efficient solar energy cells, new materials for blast-resistant structures and equipment, and low-cost, high-performance metallic inks and paste for inkjet-printed electronics. Erx Pharmaceuticals, also Austin-based, has used SBIR grants to develop new delivery systems for injectable medicines that are not soluble with water. This includes a system for injectable glucagon to treat congenital hyperinsulin that affects thousands of infants and young children. The current legislative authorization for the SBIR and STTR programs doesn't expire until September of next year. The Science Committee is holding its first hearing today in order to start the process of timely oversight and reauthorization consideration. There are still ways to improve SBIR and STTR and assure taxpayers are getting the greatest return for the investments of their hard-earned dollars. Instances of fraud and abuse continue to be problematic. Objective measurement of results across all participating federal agencies is needed. It is also important to examine if the current funding levels, the taxes on basic research, are hurting fundamental scientific research. Any increases would necessarily reduce our nation's primary investments in basic research at a time when U.S. global leadership is threatened. As members of this committee know, China is set to overtake the U.S. in R&D spending as soon as 2020. Madam Chairwoman, I look forward to hearing from our panel of witnesses today who are all experts in their own right and who represent federal agencies and research universities about these and other issues. Thank you, and yield back.
Thank you, Mr. Smith, and I now recognize the ranking member of the full committee for a statement, Ms. Johnson.
Thank you very much, and good morning. I'd like to thank you, Madam Chair, for holding this hearing today to examine the Small Business Innovation Research Program and the Small Business Technology Transfer Programs and related technology transfer issues. And I'd like also to thank the chairman of the full committee for ensuring that the Science Committee members have the opportunity to weigh in on reauthorization of these important programs. The United States has long been a nation that nurtures innovation. The number of small businesses has grown by 49% since 1982. And today's 28 million small businesses make up 54% of all U.S. sales. The invigorating startup culture we have seen for the last decade and a half has contributed to this growth and has given an extraordinary economic and social benefits. The first SBIR program was at the National Science Foundation and was started in the mid-1970s to support small, high-tech firms' ability to compete for federal R&D grants. This program grew to a government-wide program in 1982. Today, the program receives approximately $2.2 billion from funds set aside from the Federal Research and Development budget. The SBIR and STTR programs are funded from a set-aside from agencies' extramural R&D budgets. They are only R&D programs that are funded in this market. While stability and continuity in the programs are important goals, the SBIR and STTR programs are just one tool in a much larger R&D toolbox that agencies draw from to meet their missions. The SBIR and STTR programs were last authorized from fiscal years 2012 through 2017. During that time, the programs grew by 30%. In addition, the 2011 reauthorization introduced many new requirements and flexibilities for the agencies. Before we reauthorize the programs, it is the responsibility of this committee to review how the new policies introduced in the last reauthorization have been implemented, how well the programs are achieving their goals, and how they might continue to improve and how the programs fit into the larger federal research and development enterprise. Our job on the Science Committee is to help ensure the health and sustainability of this entire enterprise. One particular issue I hope our witnesses can address is women and minority participation. According to the National Academies, agencies are doing well in all of the main goals of SBIR and STTR programs, except for participation and innovation by economically and socially disadvantaged groups. I have spent my entire political career working on increasing female and minority participation in STEM, starting in the early 70s, I might add. I'm glad to say that we are not doing much better. I'm sad to say that we're not doing much better today than when I started. SBIR cannot solve disparities created earlier in the pipeline. However, we know that women and minorities receive less encouragement and support to become entrepreneurs. I'd like to hear from our witnesses today how agencies can help address this disparity through the SBIR and STTR programs. I thank the witnesses for being here today, and I look forward to the comments and recommendations for future legislation. Thank you, Madam Chair, and I yield back the balance of my time.
Thank you. And now let me introduce our witnesses. Our first witness today is Dr. Pramod Khargonekar, right? Assistant Director for the Directorate of Engineering at the National Science Foundation. He was appointed to serve as Assistant Director in March 2013. In this role, he leads the Engineering Directorate with an annual budget of more than $900 million, which funds engineering research and development and education, cultivates an innovation ecosystem, and develops next-generation engineers. He previously served as Deputy Director of Technology at ARPA-E at the U.S. Department of Energy and served as the Dean of the College of Engineering at the University of Florida. He received his bachelor's degree at the Indian Institute of Technology, Bombay, and a master's in mathematics and doctorate in electrical engineering from the University of Florida, Gainesville. Our second witness today is Dr. Michael Lauer, Deputy Director for Extramural Research at the National Institutes of Health. In this role, Dr. Lauer serves as the principal scientific leader and advisor to the director of the NIH on all matters relating to the substance, quality, and effectiveness of the NIH Extramural Research Program and Administration. Prior to joining NIH, he served as a division director at the National Heart, Lung, and Blood Institute. As a board-certified cardiologist, he received education and training at Albany Medical College, Harvard Medical School, and Harvard School of Public Health. Our third witness today is Dr. Patricia Dehmer, Deputy Director for Science Programs in the Office of Science at the Department of Energy. The Office of Science supports research at 300 colleges and universities nationwide, at DOE laboratories, and at other private institutions. She has served in a number of positions at DOE, where she began her scientific career as a postdoctoral fellow at Argonne National Laboratory. She received a Bachelor of Science degree in chemistry from the University of Illinois and a PhD in chemical physics from the University of Chicago in 1972. Our final witness today is Ms. Jilda Garton, Vice President for Research and General Manager at Georgia Tech Research Corporation at Georgia Institute of Technology. She is responsible for financial and business affairs, including licensing of intellectual property created at Georgia Tech. She directs the activities of the Office of Sponsored Programs, the Office of Research Integrity Assurance, and the Office of Industry Engagement. Ms. Garton currently serves on the board of the University Industry Demonstration Partnership and co-chairs the UIDP's Contracts Accords Working Group. She has a BA in Biology from Vanderbilt University and an MS in Zoology from Louisiana State University. I now recognize Dr. Khargonekar for 5 minutes to present his testimony.
Good morning, Chairwoman Comstock, Ranking Member Lipinski, Chairman Smith, Ranking Member Johnson, committee members. Thank you for this opportunity to testify regarding the Small Business Innovation Research and Small Business Technology Transfer programs at the National Science Foundation. My name is Pramod Khargonekar. I am the Assistant Director for Engineering at National Science Foundation. The SBIR STTR program at NSF is managed within the Division of Industrial Innovation and Partnerships in the Directorate for Engineering. While NSF's primary mission is to advance the frontiers of science and engineering through basic research, the SBIR STTR program is an integral part of the NSF strategy to stimulate innovation and address societal needs. This is achieved through the commercialization of results of fundamental research. We fund small businesses at very early stages when the technology risk is high and before the private sector is normally willing to invest. Since NSF is not the ultimate customer of resulting innovations, the NSF SBIR STTR research topics are designed to address existing and emerging needs of the US marketplace and the nation as a whole. For example, NSF SBIR research brought about Symantec, which is now a global leader in cybersecurity. It was founded in 1982 by Gary Hendricks, who was funded by an NSF SBIR grant. Qualcomm, a world leader in wireless communications and computing technologies, also received NSF SBIR funding during the 80s in its early years as a small business. Its co-founder, Irvin Jacobs, recently stated, and I quote, "With one of the grants, we developed some of the first chips we did at Qualcomm, if not the first. Of course, making chips for cell phones is now about 2/3 of our revenue today, and that was the base," end of quote. In the last 4 decades, NSF has been continuously innovating and exploring new approaches to stimulating small business-based technological innovations and commercialization. In 1998, NSF SBIR introduced a new supplemental program called Phase 2B. It is a platform to stimulate NSF-funded active Phase 2 grantees to attract additional private sector funding for further technology commercialization. In addition to providing funding in varying stages, we also assist our awardees by providing them with experiential entrepreneurial education based in part on the NSF Innovation Core or I-Core program. I-Core helps entrepreneurs and their small businesses understand market needs and customers, thus increasing their chances of successful commercialization of new technologies. Another program closely related to I-Core is the Accelerating Innovation Research, or AIR. We frequently find that NSF-funded academic researchers apply for AIR grants first before pursuing I-Core training. We are seeing strong interactions between these programs and our SBIR STTR program, where researchers with NSF-funded fundamental research advance to AIR first, then go through I-Corps, and then pursue SBIR STTR funding. This pathway is getting stronger and working extremely well. We also have many other translational research programs which complement our significant investments in fundamental scientific and engineering research. SBIR and STTR are vital components of NSF's agenda to enable commercialization of technologies stemming from basic research. We at NSF take great pride in having pioneered the SBIR program concept and continue to innovate to expand its impact. Recently, there have been proposals to increase the set-aside percentages for SBIR STTR, whose ultimate effect will be to apportion a greater amount of the NSF research budget to the SBIR STTR program. NSF is the lead agency for the support of basic research at our nation's universities. Our budget for basic research has been flat during this decade, and any further diminution would reduce the very discoveries that our country needs to remain an economic powerhouse and a global leader. We do support future growth in SBIR STTR programs, but urge that such growth be enabled through an overall budget increase for NSF. NSF strongly supports a permanent reauthorization of SBIR STTR and recommends that the annual set-aside percentages for the programs be maintained at FY17 levels. Lastly, I should note that NSF participated in the interagency process to detail principles all the SBIR STTR agencies can support for reauthorization, which include permanent reauthorization, growth in program through overall extramural research growth, and maintaining flexibility. Madam Chairwoman, this concludes my testimony. On behalf of the National Science Foundation, the SBIR STTR program, and our awardees, I want to thank you for this opportunity to highlight a program that provides small businesses with the means to keep America on the forefront of innovation and stimulate U.S. economic growth. We greatly appreciate the opportunity to work with you on reauthorizing SBIR and STTR. Thank you.
Thank you. Now we'll hear from Dr. Lauer.
Good morning, Chairwoman Comstock, Ranking Member Lipinski, and members of the subcommittee. It is an honor to appear before you today to talk about how the SBIR and STTR programs fit within the overall context of the NIH research portfolio. NIH has been advancing our understanding of health and disease for more than a century. Scientific and technological breakthroughs generated by NIH-supported research are behind many of the improvements our country has enjoyed in public health. Many recent breakthroughs stem from our nation's commitment from investing in basic research, which lays the foundation for advances in disease diagnosis, prevention, and prevention, and is generally not supported by the private sector. NIH supports a broad research portfolio that includes basic science, translational science, clinical research, and population-based research at universities, academic health centers, and small businesses. Like any other investment portfolio, the key to success is diversity, which maximizes the likelihood that we will come up with transformative cures. It is important to remember that many years and financial resources are necessary to bring medical innovations into the practice of medicine. It has been estimated that it takes 11 to 14 years and approximately $2.6 billion to bring a new drug to market. While basic science lays the foundation for advancing our knowledge about the nature and behavior of living systems, this knowledge must then be applied and translated and later approved to the regulatory system before patients can benefit. The small business community benefits from all of the formative research supported by NIH. Among the 11 federal departments and agencies that participate in the SBIR and STTR programs, the NIH is the second largest funder. Examples of the types of research that we support include, but are not limited to, drug discovery, medical devices, biosensors, nanotechnology, imaging, and bioengineering. A successful example of a technology developed through our programs is Lift Labs Liftware, which creates stabilizing technologies to help people with essential tremor and Parkinson's disease. Our programs have grown significantly with the increases provided by the 2011 reauthorization. Between fiscal years 2011 and 2016, the NIH budget increased by about 4.5%, while our SBIR and STTR budgets increased approximately 30%, or 6 times as much. We are grateful for the financial and human resources support provided through the Administrative Fund Pilot Authority. We have used this authority to bolster and diversify our program outreach efforts, reaching more than 24,000 individuals from all states in the past several years, including 940 women-owned and 650 socially and economically disadvantaged small businesses. Through these and other efforts, we anticipate increased applications from these groups in the future, further diversifying the programs. The NIH strongly supports the SBIR and STTR programs. For decades, these programs have served as vital sources of federal funding for innovative American small businesses. The program should be permanently reauthorized to provide us all with much-needed long-term certainty. However, future growth in SBIR and STTR programs should be realized through overall extramural budget increases for each agency. For example, the Congress provided NIH with a $2 billion increase this past year, which meant that our SBIR and STTR budget increased by 12.4% from the previous year, nearly twice the agency's increase. Scholars have noted that the biomedical research enterprise now suffers from hyper-competitiveness, with increasing numbers of researchers competing against each other for relatively fewer available dollars. Historically, NIH success rates have been about 1 in 3, and they are now down to less than 1 in 5. We are concerned that dedicating an ever-increasing proportion of NIH's extramural research dollars to these two specific programs would threaten the diversity of the research portfolio, a portfolio that succeeds precisely because it is so diverse. In our judgment, it would be more effective for overall R&D budgets to increase so all programs benefit. Furthermore, it is imperative that NIH and other federal agencies participating in the program be provided with the resources necessary for effective administration, oversight, and outreach, as well as reasonable flexibility on award size and sequencing, consistent with the diverse needs of small businesses in different industries and technology areas. This concludes my statement. Thank you for your attention, and I look forward to answering any questions you may have.
Thank you, and we'll now hear from Dr. Dehmer.
Thank you, Chairman Comstock, Ranking Member Lipinski, Chairman Smith, and Ranking Member Johnson from the full committee and members of this subcommittee. My name is Pat Dehmer, and I am the Deputy Director of the Department of Energy's Office of Science, where I oversee all of the science programs. The DOE SBIR STTR Program Office is one of 9 reporting to me. The Office of Science has managed the department's SBIR STTR program since the formation of SBIR in 1982. We work with the 6 science outlay programs in the Office of Science, with 4 applied energy technology offices, with the Office of Environmental Management, and with the Office of Defense Nuclear Nonproliferation within the National Nuclear Security Administration. These 12 offices together contribute about $200 million annually to SBIR, STTR, and the Office of Science is about 2/3 of this funding. Since its establishment as a separate agency within the Department of Energy, the Advanced Research Projects Agency Energy, or ARPA-E, has managed its own small SBIR program about $8 million annually, with initial awards in 2012. During the past few years, we have experimented with some new approaches, some resulting directly from the Reauthorization Act of 2011, which I'll talk about in a moment. But first, I want to mention one other program. In 2013, we began something called the Technology Transfer Opportunities, or TTOs, as part of our funding opportunity announcements. TTOs enable small business to use technology that has been developed using DOE funding at our national laboratories or at universities. TTO awardees are assigned rights by the institution owning the technology to perform R&D on the technology during Phase 1 or Phase 2 grants. In addition, the Research Institute provides the awardee with a no-cost 6-month option to license the technology. In 2015, 10 Phase 1 and 2 Phase 2 TTO awards were made representing technologies from Michigan State University and from 4 of our Department of Energy national laboratories. When the 2013 cohort, the first cohort, completes, we will begin an assessment of the outcomes of this particular experiment. I'd like to turn now to some important features of the 2011 Reauthorization Act, particularly as they might relate to your consideration of the forthcoming reauthorization. The 2011 Reauthorization Act created a pilot program that allowed agencies to use up to 3% of SBIR program funds to improve the administration of these programs. DOE used from 0.6 to 0.9% of program funds annually for some very important improvements. First is the improvement in our award timelines. By adding small amounts of funding to accelerate the development of our new Office of Science-wide web-based grants management system and introducing a few process changes, we were able to reduce the time from the close of a solicitation to Phase 1 awards, actual awards, by a factor of 2, from 8 months to 4 months. That's a very substantial improvement, and the opportunity to have this flexibility was critical to us. A second thing that we did with this authorization was an important outreach activity. We created a Phase 0 assistance program to help underrepresented small businesses apply for SBIR STTR funding. In this program, we target applications from states with historically low SBIR STTR submissions and from women and minority-owned businesses across the nation. The Phase 0 assistance program helps awardees with letter of intent writing, Phase 1 proposal preparation, review, and submission, training and mentoring, communications and market research, technology advice, and consulting on areas of intellectual property. In just 3 funding opportunity announcements, we received more than 500 applications for the Phase 0 assistance program, and we provided services to 165 participants. Again, we plan to assess the effectiveness of this after a year or so of this program being in operation. The Reauthorization Act of 2011 also permitted us to make sequential Phase 2 awards. These awards permit us to fund additional R&D to complete Phase 2 research if necessary, and to assist with transition to commercialization. In 2015, 17% of our Phase 2 awards were sequential Phase 2 awards. As you think about the reauthorization in 2017, we'd like to take this opportunity to present our thoughts. We strongly support permanent reauthorization to provide federal agencies with long-term certainty and stability. We strongly support the existing flexibilities provided on award size and sequencing, and for example, that helped us innovate and begin the Phase 2 assistant pilot program. And finally, like my colleagues, we support maintaining the SBIR STTR set-asides at the 2017 levels, which represent more than a 30% increase over the FY 2011 level. Thank you very much for the opportunity to talk to you. I appreciate the committee's interest in this important topic, and I will be happy to answer your questions.
Thank you. I now recognize Ms. Garton.
Good morning, Chairwoman Comstock, Ranking Member Lipinski, Chairman Smith, and members of the subcommittee. My name is Jilda D. Garton, and I serve as the Vice President for Research and General Manager of Georgia Tech Research Corporation at Georgia Tech. Georgia Tech's a comprehensive public university with more than 25,000 undergraduate and graduate students. We reported more than $765 million in research expenditures in 2015, with research funding from a variety of federal and non-federal sponsors. Private industry sponsors about 13% of the total research activity at Georgia Tech, and includes several dozen SBIR and STTR subcontracts. And we do a little tech transfer at Georgia Tech. Georgia Tech is among the top 25 universities in the number of U.S. patents granted in 2014, and over the past 5 years, 81 companies have been formed based on Georgia Tech technologies. SBIR and STTR programs are important to universities because these are important to our technology transfer ecosystems. America's universities create amazing new inventions every day. My own institution will receive about 350 invention disclosures this year alone. As creators and stewards of these inventions, we have an obligation to make them available to the public in the form of new products, new drugs, new assistive technologies, and new services. University technology transfer works with the private sector to move technologies from the laboratory into companies that can develop them, invest in them, and commercialize them. It's this ecosystem that we want to develop. Universities value the SBIR and STTR programs, and we generally support their permanent reauthorization at their current set-aside levels. And that's because these are important parts of that ecosystem. In thinking about how to discuss our experiences with the SBIR and STTR programs, I thought it might be helpful to offer an example that illustrates how the SBIR program in particular interacts with other parts of the innovation ecosystem on my campus to support new ventures that are trying to bring new technologies onto market. I've given you a couple of examples also in my written testimony, including one woman-owned company. Pindrop is an Atlanta-based company that markets a way to combat telecommunications fraud through something they call acoustic fingerprinting. The technology resulted from Department of Defense-funded research that was conducted by a professor in the College of Computing and his students. The invention was disclosed to GTRC in 2010 and licensed to a new company in 2011. Pindrop's management participated in and was mentored by Georgia Tech's NSF I-Corps program, and we're very proud to have been one of those original 3 nodes. The company went on to work with our SBIR Assistance Office, which helps companies that are formed in our environment reach out and identify opportunities in SBIR and STTR programs at various agencies and prepare proposals and submit them in a way that will help them get funded. Pindrop won one of those SBIR awards and went on to develop their technology. And in January 2016, Pindrop received Series C investment from Google Finance. They're on their way to being a major company in this space. Pindrop's story shows how development inside the university readied the technology for the marketplace and de-risked it. SBIR funds increased the likelihood that the company would become successful. As it developed its technology, it became more attractive for private sector investment. Pindrop's story also demonstrates how long it takes and how much investment is actually needed. You've asked us for advice in areas of potential improvement as you consider the reauthorization of these programs. And I would be remiss if I did not point out that Pindrop would not have been possible without basic research. As the federal investment in research and development conducted at U.S. universities is constrained, it's important to acknowledge that funding basic science and engineering has to be a priority because that's what fills the pipeline of discoveries that feed the innovation ecosystem. Universities are interested in seeking balance. If I have one thing to offer for your consideration, it would be to focus on the overall fiscal budgets for the research funding agencies and ensure robust investment in basic and applied research to support the highest quality peer-reviewed research. It remains the case that there's a funding gap that sometimes prevents universities from moving new discoveries and technology into the marketplace. Accordingly, members of the higher education community have recommended creating the SBIR program that would focus on commercialization that we often call Phase 0. These awards could be used by universities to engage in prototyping, mentoring, and supporting market readiness initiatives. Finally, I would like to suggest that we could all benefit from additional information about the federal SBIR and STTR funding. Dr. Lauer and Dr. Dehmer have talked about a number of efforts at their agencies to analyze the success rates of the programs and how the companies perform after award. These objectives, measures of performance, and indicators of performance would be very welcome. I'd like to thank the subcommittee for the opportunity to provide our insights from the university perspective on the important question of reauthorization of the programs, and I look forward to answering your questions.
Thank you. I now recognize myself for 5 minutes for questions. I guess this is a question to all of you. How do we measure success with the SBIR and STTR programs? You know, things like job growth, employment growth, patents. How do you judge it, and what are you looking at?
I mean, that's an excellent question, and the National Academy's study does talk quite a bit about metrics for success of the SBIR, STTR programs. we look at it as sort of as a whole, as a program as a whole, which is really aimed at taking discovery in the lab to the real world. And we also think about I-Core and other innovation programs as part of the overall ecosystem. In terms of, in that regard, it's phase 2B funding, which really makes it possible for the company and its technology to become a real world company with employment and revenues. And there, the numbers are actually quite encouraging. A lot of our vast majority of phase 2B companies go on to become very successful companies and have revenues many years out into the future. We also look at intellectual property generated by these companies. And probably most importantly, it's the people, because the people who go through these experiences then go on and start new companies throughout their careers. So I think one has to look at the whole system and look at the metrics from that point of view.
Okay, and I know a lot of you would use the word ecosystem, which I think is very important, how we create that innovative ecosystem. So, with our universities, with our businesses, and how do we get that ecosystem, getting the input from the private sector too. So as we're investing in these things, there's sort of a leveraging factor that gives it that extra oomph to start doing things. How do you all see that playing out in what you're doing?
So for NIH-funded research, there are some additional components of the ecosystem that are important for success metrics, and those would include moving products onto clinical trials, getting them through the regulatory system, working with CMS and other payers to see whether or not a product, once eventually successful, will be reimbursed in clinical practice, and then also working with professional societies to realize the incorporation of new technologies into standard clinical practice.
Good point. Thank you.
Well, we've had quite a bit of experience over the last 5 to 10 years of looking at success of non-traditional research programs. We started something many years ago called the Energy Frontier Research Programs. And how do we measure their success? We do it in part by the standard metrics of counting publications, licenses, and things like tech transfer and how many small businesses and industries are involved. In reality, it's an extremely difficult topic to measure success of non-traditional research and development programs. Not only have I been involved with that, but for the past 5 years, I've been involved with measuring success of programs that do STEM workforce development training. Very difficult. So one of the things that we've done actually in the last year is bring a new person into the SBIR STTR program, a PhD researcher, whose function is going to be to look at how we measure success and to follow on with some of the programs that we've started and that the traditional SBIR STTR programs do.
Thank you.
One of the ways that we look at measuring the success of our own technology transfer efforts is to look at whether or not our patents or our licensed intellectual properties are being utilized at various points after they've either been protected by patent or licensed under other circumstances, and ensuring that those technologies are still being used at 3, 5, and 7 years after the license. And I think that's one of the measures, rather than counting the numbers of patents per se, but looking at whether or not those technologies are being used by the private sector and being used to either do additional research or being used incorporated into new products and services. So looking at whether or not the intellectual property we're creating is being used is one of the important metrics for success, both of the university technology transfer, but also of the SBIR receiving company, because it will itself begin generating intellectual property, and we want to see if that's being used as well.
Okay, and so I'm running a little over my time, but I did want to ask, since I want to give a shout out to my local technological community, the Northern Virginia Technology Council is very good at working with all of our technology companies, but they also highlight emerging companies and doing things like that, and they're very good at publicizing it within communities, and that in turn kind of helps get more support there. Are we seeing that utilized too, having the kind of leverage there that, or maybe since my time is up, I'll just recommend any way that we can have others, such as, NVTC in my community, I think is very good at it, but maybe I'd recommend, others to use that as a model, because I think they're particularly helpful in highlighting the whole ecosystem, and that's what they're all about, is that ecosystem and supporting it. They support STEM education, they support the emerging companies. They exist by virtue of a lot of support from the big companies, but everyone in it is driving the ecosystem, and I know they work a lot with our universities too, so if looking at that as a model, I just throw that out because they're a great group for us to work with. And I now recognize, who am I? Oh, no, you want me to, okay. So I'm recognizing Ms. Johnson. We're going out of order here, so Ms. Johnson can have her question again. Thank you.
Thank you very much. I'd like each of you to respond to the fourth statutory purpose of the SBIR and STTR programs is to foster participation in innovation and entrepreneurship for socially and economically disadvantaged persons. The national academies have consistently found that agencies are struggling to achieve this. My concern over the years has been integrating these populations. It's now become a more concern because that's our growing population in this country. And I'm concerned that a lot of our brain power is not being utilized. So could you comment on what you're doing, or whether it's difficult, or what we could do to attract that population more?
So I think that's a really excellent and difficult question. We at NSF are very focused on this topic. Our latest initiative, NSF Includes, which is a foundation-wide initiative, is aimed exactly at attracting women, underrepresented minorities, people with disabilities, people from low socioeconomic status into science and engineering fields. In addition, in the SBIR program, this has been a really major area of focus and concern. And as you correctly noted, the progress has been quite slow. There are several things we are doing. One of the ways in which we use our administrative fee is for very strong outreach programs where our program officers, and there is a group of program officers whose full-time job it is to run our SBIR, STTR, go out to these communities in terms of outreach. The Phase 0 program at NSF, it has two objectives, one of which is explicitly to reach out to women and underrepresented minorities in terms of forming companies. So this remains a major priority for the foundation, for the SBIR program, and we would love to see faster and stronger progress, and we will continue to work on this problem till we achieve success. Thank you.
Thank you.
Thank you, Congresswoman. This is a very high priority for NIH. On an NIH-wide level, we've set up an Office of Workforce Diversity, which is specifically focused on this. The National Institutes of Minority Health Minority Health is expanding its R01 program. Some of the institutes, like the NHLBI, have actually set up specific units that are devoted to increasing our profile in disparities research. And then within SBIR, we also are engaged in using administrative funds for extensive outreach efforts. The Phase 0 programs are also an opportunity to bring in previously disadvantaged groups into the fold and increase the likelihood of their success.
Thank you.
Well, thank you for that question. In the Department of Energy, we have a particular challenge with women and underrepresented minorities because the work that we do is primarily physical sciences, and the pipeline for bringing those folks into physical sciences has never been cracked to the extent that I would like to see it. And by the way, my own personal time with this goes back to yours in the 1970s. Within Within the SBIR STTR program, we're doing several things. We're definitely increasing our outreach to everyone, as my colleagues have mentioned. And one of the reasons we started the Phase Zero Assistance Program, which is somewhat different than the other Phase Zero programs described, is specifically to target women and socially and economically disadvantaged persons. It's a huge challenge in the physical sciences. You know, I've observed in my own career, which dates back to the early 1970s, thanks to my bio, which didn't expunge the date of my PhD. I can remember when I was a student and my colleagues who were women and minorities talked of quotas for medical school and other kinds of professional schools, very small quotas in the few percents, not double digits. Today, medical schools graduate 50% women, veterinary schools graduate nearly 100% women, but the physical sciences have not kept pace at all with that. So that's one of the things the Department of Energy is particularly keen to crack, and we've done so both in the core research programs, in our workforce development programs, and in our SBIR STTR programs.
Thank you.
Well, Georgia Tech is, as a public institution, really takes its mission and economic development in Georgia very seriously. We have what we call the Enterprise Innovation Institute, which has a number of offices. The Advanced Technology Development Center is one of the oldest university-based incubators in the country, and it is open to companies from our entire area. Within EII, we also have the SBIR Assistance Office, which helps small businesses identify SBIR and STTR opportunities, learn about the programs, and learn how to apply to those programs. So that is an office that's available to support all companies that are created in the environment, access SBIR and STTR funding. We also operate the Manufacturing Extension Partnership, which helps businesses in Georgia become more competitive and sustainable.
Thank you very much. My time's expired.
Thank you. And I now recognize Mr. Westerman for 5 minutes.
Thank you, Madam Chair, and thank you to the witnesses for sharing with us today. Dr. Garton, you shared the success story of Pin Drop, and I appreciate your testimony because it gives us a real-life example that makes it easier to understand the importance of research. Bill Gates once said, who is obviously one of the great innovators of our time, he said that governments will always play a big part in solving big problems. They set public policy and are uniquely able to provide the resources to make sure solutions reach everyone who needs them. They also fund basic research, which is a crucial component of the innovation that improves life for everyone. Having an engineering background and sitting on this committee, I really enjoy getting to go see where this research is being done. I made a trip out to the Berkeley National Research Lab, and I saw some very exciting research there and biofuels and creating economical methods to use our bioresources to make all kinds of fuels and chemicals. I saw some innovative research with nanotechnology, with a material that if it's envisioned that if you could create a filter out of this material, you could essentially clean the entire stack emissions from a coal-fired plant. Very exciting stuff. In my home state, the institutions of higher learning are doing some neat research. The University of Arkansas Institute for Nanoscience and Engineering Technology, just amazing some of the things that they're doing. What I would like to ask you, we've talked about some success stories, but could you share with us maybe one exciting new innovation that's on the horizon that's taking place at your organizations, and how close are we to seeing those become reality? And start with you, Dr. Khargonekar.
I think one of the areas that we are very excited about in the engineering directorate is our focus on advanced manufacturing. So we have made, first of all, historically, NSF has made pioneering contributions in that area. The whole 3D printing industry came out of NSF-funded research in the 80s. In recent years, last 2-3 years, we've been investing in cyber manufacturing that would shape the factories of the future by leveraging cyber technologies, sensors, communications, computation, networks, and things of that nature. We are investing in cellular biomanufacturing. So as cells become therapies, how will we manufacture those? So we are sort of creating basic research in manufacture of cells. And a third area where we are making some very exciting investments is in scalable nanomanufacturing. So we invested a lot of funds in nanotechnology and nanoscience. And the question we are asking is how will we manufacture the products at scale and at cost? So one example is we are using, we funded some research that will use roll-to-roll printing as a way to manufacture these products, which if it works, would be extremely cost effective and produce products that would have big impacts. So these are some of the examples that we are very excited about.
Thank you. Dr. Lauer?
Thank you, Congressman. This is a very exciting time for biomedical research, and two themes are high throughput technologies and big data. So looking at complex systems and taking advantage of current exploding information technologies. So some examples include three-dimensional mapping of neurons within the central nervous system in health and disease, quantification of DNA and gene sequencing technologies, drug screens for rare diseases. There are literally millions of potential compounds that could be effective for diseases, and we're now being able to figure out ways in which we could identify potentially beneficial targets in a short period of time. And then another interesting one from a different side, from a purely clinical side, would be the incorporation of patient-reported outcomes into electronic health records.
Thank you.
Well, in preparing for this hearing, I looked at a number of examples of outcomes from SBIR investments. I don't see them all because I don't look at them day to day. But one of them struck me as extremely important, and that is a small company in Lansing, Michigan, near Michigan State University called NioWave Incorporated. They received a number of SBIR, STTR awards over the last 10 years or so, to build superconducting linear accelerators, which sounds kind of techy. But one of the things that they did in 2015, they produced molybdenum-99, Moly-99, by fissioning uranium using one of the superconducting linear accelerators. So the decay product of Moly-99 is technetium-99, and that's used in 30 million diagnostic imaging procedures annually. The United States has no production of Moly-99. It's all imported. And so NioWave is going to begin, I hope in a couple of years, 2016 or 17, producing Moly-99 using this linear accelerator technology. If so, it would be a remarkable achievement. So that's the one that struck me as potentially the most impactful.
Well, as you can imagine, at Georgia Tech, there are technologies emerging all over the place, and it's hard, as with Dr. Dehmer, it's hard to keep up with all of them. A couple of the areas where we really see the next technologies emerging that we're all going to be talking about in 5 and 10 years are areas like cell-based manufacturing, where we're beginning to be able to reduce these technologies to practical application. Some of the membrane technologies for carbon sequestration, and it's similar to the examples that you cited, are probably going to go a long way toward helping us deal with controlling the emissions out of our carbon-producing factories and other sources of carbon in the atmosphere. And there's other technologies that are closer to the market, like our new drug delivery technologies that will allow us to deliver vaccines across the world in using delivery methods that don't require refrigeration and can be self-administered. So there are some technologies that are emerging all across the spectrum that are just waiting to burst out there.
Thank you. Thank you, Madam Chair, for indulging a little extra time. I yield back.
Thank you. Okay, I now recognize Mr. Lipinski.
Thank you. I had mentioned in my opening that early returns show that Innovation Core, those I-Core teams have shown more success, seem to show more success in the SBIR program. So I wanted to ask the witnesses what they could tell us about what they have seen or their just thoughts moving forward. I want to start with Dr. Lauer, because I know that you're making I-Corps available to SBIR grantees at NIH.
Yes, thank you, Congressman. So far, 38 companies have gone through the I-Corps program. We've had 2 cohorts. Our next cohort is kicking off on June the 19th with 21 companies, and then we're planning an additional 2 cohorts in 2017. And what we would say so far, it's still too early on in the program to talk about long-term outcomes, but the responses have been quite positive. Over 90% of the participants have considered the experience to be worthwhile or excellent. And we've seen some interesting examples. One is a company called CrossLife Technologies, which is working on diagnostic tests for viruses like dengue, and some of the work that they're doing may also apply to Zika as well.
Thank you. Dr. Khargonekar, do you have anything to add to that? I know you mentioned where that sort of fits in what a lot of researchers will do.
So we remain very excited about the I-Corps program. It is having tremendous impact on the research community. We constantly hear that those who have gone through the program are transformed by the experience, and they think about their research quite differently than they did before. We are partnering with a number of federal agencies to share what we have learned about I-Corps, including NIH and DOE at this table, but many others. We are also scaling it nationally. We have our FY17 request has plans for up to 8 to 9 nodes and 71 sites and 230 teams. State of Ohio has adopted I-Corps methodology. So we feel that there is tremendous opportunity for the nation to take the learnings from I-Corps and the program that NSF has pioneered and really make it available to all scientists and engineers who want to take part in it. Thank you.
Ms. Garton, do you have anything to add about how I-Corps can help those SBIR grantees?
I believe the I-Corps program actually is a good entree to entrepreneurship for a lot of faculty and graduate students who have an invention and are trying to think about a way to commercialize it. So the I-Corps program really does provide that entree for those individuals who are developing the technology in the direction of creating a startup company and launching it. And I think it's a very good way to pull people into the program that leads to SBIR funding. And so I really view that as a piece of the continuum of the development of technologies. One of the most exciting things I think I've seen really comes out of the pin drop example, where we have a laboratory that successfully launched a startup company, developed it through the I-Corps program, received SBIR funding, and then went on to be successful in the private sector. The graduate students who are coming along as the next cohort of students in that laboratory are bringing invention disclosures forward. They've got philanthropic funding and other funding that they're taking advantage of, and they're going to be your next I-Corps cohort. So you've created an example that others can follow.
And Dr. Dehmer, I know the national labs don't have I-Corps, but something very similar, LabCorps. Have you seen the impact of this, or what do you hope to be the impact?
Well, actually, we're also a participant in I-Corps. Early on, the Office of Energy Efficiency and Renewable Energy, which is one of the largest contributors to SBIR, signed a 1-year MOU with NSF to participate in I-Corps. They subsequently extended that to 5 years, and they've been sending cohorts to that for the past few years. That same office also began LabCorps, and it's my understanding that it's been very well received and very popular with the laboratory scientists. So yes, we're part of both I-Corps and LabCorps.
Very, very quickly, on another connected subject, Ms. Garton, NSF has come out with a solicitation to continue funding for the I-Corps nodes. I'm glad that this is continuing. However, it's noteworthy that the solicitation, that the funding for the nodes drops to a small fraction of its original amount by the 5th year of the award. I understand the idea is that other sources of funding for the nodes will step in as federal funding declines. I have some concerns about this. I was wondering what your thoughts were on this. Has Georgia Tech identified other sources of funding for its node that could step in if federal support declines?
We certainly would endeavor to work in that direction if that is the direction for the program, and I would have to get back with you specifically and talk with the folks that are developing the proposal about specific sources of funding that have been identified. Maybe I could take that question later, but we would certainly, if that's the direction we want to go, that's what we will try to do, but it will be a challenge.
Thank you. I'm way over time. I yield back. Thank you.
Thank you. I now recognize Mr. Palmer.
Thank you, Madam Chairman. Mr. Khargonekar, the idea for the Small Business Innovation Research is to fund innovative technologies that the private sector may not be inclined to fund. In other words, address the problem of underinvestment in R&D. Is the program serving this purpose, or is it focusing on proposals that are based on commercial viability, technical merit, or an agency's agendas?
So the NSF SBIR program is very much focused on technology risk, very early stage where there is a discovery or invention that has some commercial potential, but it's very far from being worthy of private sector investment. So that's where we come in and put funding through the phase 1, phase 2, phase 2B sequence to see if the technology risk can be reduced or even eliminated. And once that happens, private sector feels more comfortable coming in because that risk has been removed. So I would say absolutely, our investments have been very much focused on reducing the technology risk and making the technology more mature so that private sector at that point can come in and scale the technology and commercialize it.
But are any of these grants that the private sector would have, are research dollars the private sector would have provided? Are you displacing private sector investment?
In my opinion, no. I mean, I think great example of that is our phase 2B program. So let's say you are an inventor or a discoverer, you come up with something, you go through the phase 1 and phase 2. In phase 2B, we require a 2-to-1 match. So it's only at that point that the private sector is brought in, that private sector feels that they can come in where the risk has been reduced substantially. And so I don't think it's displacing the private sector, at least at NSF, because we are at such early stage of the technology creation.
Is any of it driven more by an agency's agenda? And Dr. Lauer, or you can respond to that as well.
Thank you, Congressman. There has been some work that's been done looking at whether or not NIH support is crowding out private investments, and we'd be happy to share some of that with you in follow-up, but it seems that most people are concluding that the answer is no, and that the work that NIH is supporting is indeed work that otherwise would not have been supported by private sector. Our primary goal is to enhance our understanding of the knowledge of living systems and then apply that knowledge to improve health and reduce burdens of disease. That's our agenda, and as best as we can tell, we're meeting that.
Thank you. Dr. Dehmer, are any of the grants primarily determined by the Department of Energy's agenda, or are they strictly looking at the research that or the project?
The way that we determine topical areas in our funding opportunity announcements is...
Could you get a little closer to the microphone?
The way that we determine the topical areas for the funding opportunity announcements is by going out to all of the programs and having them suggest the topical areas and the subtopics that we put out in the FOAs. I can't speak to all of the subtopics, but certainly in the Office of Science, there are a number of topics that probably the private sector wouldn't be investing in the very early stages.
This is a question for all of you. The Inspector Generals at federal agencies seem to identify and pursue instances of fraud and abuse in these programs with a fairly high degree of regularity. Are there facets of the programs that seem to invite wrongdoing? Are there identifiable characteristics that you look for bad apple applicants? Is there a way to vet these applicants to avoid fraud?
We at NSF certainly are very, very focused on this and try to do our very, very best to make sure that the amount of fraud is as minimal as possible. We have an extensive process of vetting the companies and looking at their financials and making sure that these are legitimate businesses with accounting and so on and so forth. So we can give you more detail about the process we follow at NSF to ensure that our recipients are worthy companies.
I would say the same. Our SBIR grants go through the same rigorous vetting and review and oversight as all the grants at NIH.
Yeah, I'll echo that. I actually engaged in discussion on this with the director of the SBIR, STTR Programs Office just this week. And it's a complicated topic. We'd be happy to get back to you on that if you like.
What I'd like to know, Madam Chairman, is in these cases where there have been abuses of the program, what our remedies are, if there's any effort to recover this, because we are talking about oversight over taxpayer money.
Okay,
With that,
thank
I'll
you.
go
Well,
back.
I know we're going to have votes here at 11:15 to 11:30, so I'm going to have to move on. But I now recognize Ms. Bonamici.
Thank
5
you,
minutes.
Chair Comstock and Ranking Member Lipinski, for holding this hearing. To our witnesses, the SBIR and STTR programs have helped universities and small businesses not only in my state of Oregon, but of course across the country. Megavax is one example, Oregon Health Science University-based startup that's received funding from the programs. They're developing vaccines and immunotherapies for chronic and recurring viral infections, and they're now, based on this research, recruiting the first human volunteers for a clinical trial on promising HIV vaccine. So great programs, but I had a conversation recently with our institutions of higher education and some innovative small businesses, and a couple things came up, and I'm going to ask you about those. First, I heard about a woman who has a PhD in cancer biology, decided not to go back to work after her kids were born because science funding is complicated and tenuous. Also heard from a small business, creative small business owner, very innovative, who said that they don't even look at the SBA for funding because the application process is complicated and time-consuming. This is someone who's a patent attorney with an MBA, so if it's not user-friendly to somebody like that, the first issue is what is being done to address the complication and the I guess, tenuous nature of science funding in general. The second issue that came up that I'll ask you to address is the funding gap between Phase 1 and Phase 2. And we heard about up to 6 to 9 months can go by between Phase 1 and Phase 2. And if it's a small business with just a couple of employees, they don't know what to do for that time, and they're really it's really killing some efforts and what could be some very innovative products. So I guess I'll start with Dr. Khargonekar. If you could discuss the whole process and how complicated it is and uncertain, and the funding gap, please, between Phase 1 and Phase 2. Thank you.
So the Phase 1, Phase 2 gap has been a significant focus for the foundation. Prior to 2015, we added a Phase 1B supplement to Phase 1 grantee so that they would have some additional dollars so that the gap could be addressed to some extent. But in 2015 and 2016, we made a significant change. We did several things. We increased the Phase 1 duration to 12 months. We increased the Phase 1 amount to $225,000 from $150,000, so that gives you more dollars and longer runway. And then we changed the deadline so that you can submit the Phase 2 grant after 8 months of Phase 1 start. So that allows, it doesn't completely eliminate the gap, but it allows it to be much smaller than it has traditionally been. And I'll add one final point. We rely a lot on the Phase 1 interim report to know if the technology is really viable, because we want to be responsible stewards of taxpayer dollars. So with these changes and making sure that the Phase 1 interim report guides us in terms of the Phase 2 decision, we feel that we have taken a number of steps that would address the funding gap that you pointed out, and it's an area that we will continue to work on.
Thank you, Dr. Lauer.
Thank you, Congressman. We do recognize that it takes too long for applications to be processed, and so beginning about a year ago, we have made a number of administrative steps to streamline the SBIR application process, and we hope to have some promising metrics available for you before too long. Regarding the Phase 1, Phase 2 gap, we have a mechanism called Fast Track where one can apply for combined Phase 1, Phase 2 at the same time. The idea is that if you meet certain metrics through Phase 1, you automatically move into Phase 2. And that has been growing, and it's now about 25% of our Phase 2 programs go through Fast Track, go straight from Phase 1 to Phase 2.
Terrific, thank you.
We've done similar things to what's just been described. We have a fast-track program, and we've made a number of changes in how the awards are handled so to reduce the gap. Also, in terms of the complications of application, we've tried using a new electronic application system to streamline that somewhat, and as I mentioned in my own testimony, we reduced the time from the close of the FOA to the actual award by a factor of 2, and so we're trying very hard to make things easier for the applicants.
Thank you. Ms. Garton, anything to add?
Well, we don't, Georgia Tech as a university is not a direct recipient of SBIR funds, and so the funding gap is less obvious to us, but in our subcontracting practices, we certainly do notice the discontinuity between Phase 1 and Phase 2 and try to work with our SBIR companies that are funding us under subcontracts to support their proposal efforts.
And are you sensing the same sort of discouragement that I heard from a couple of people in this conversation about it's so complicated and tenuous? And for the record, I was not in Congress when the Budget Control Act passed, not part of the sequestration and those across-the-board budget cuts. But are things getting better out there? Or
it is very, very tough on the basic science side. The pay lines are such that it is very hard for faculty to get their basic and applied research programs funded, and that's really the balance part of the question. Do we have enough funding going into overall research programs, and what are the pay lines? It is very difficult. I think Dr. Lauer talked about it in his testimony.
He did. We got that message clearly in Dr. Lauer's
And
testimony.
yes, we are feeling that.
Thank you. My time has expired. I yield back. Thank you, Madam Chair.
I now recognize Mr. LaHood for 5 minutes.
Thank you, Madam Chair, and I want to thank the witnesses for being here today in your testimony. I want to take a brief moment just to highlight the impact of the SBIR program in my home state of Illinois. The SBIR program is an important source of investment in new technology for the state of Illinois. Since the program's inception, Illinois has received over $600 million in SBIR funding, creating thousands of new jobs, new products, and new services. As others have mentioned, the recent National Academy reports on the SBIR and STTR program in the civilian agencies cite a very strong record of commercialization and return on investment, as well as strong linkages to the university and basic R&D infrastructure within the country, which is clearly evident in the state of Illinois. With the past, I guess my question, with the past successes of this program in mind, as we look to reauthorization of SBIR and STTR, what top recommendation would each of you make for improving the SBIR and STTR programs to more efficiently and effectively promote innovation and job creation? Doctor?
Yeah, so we support permanent reauthorization. We support maintaining the flexibility in the program. That, I think, has been very, very important, at least for the National Science Foundation, to maximize the value to society and to the taxpayer of SBIR-funded research. Those are some of the top recommendations that I would make is please maintain the flexibility in the SBIR program.
Thank you.
Yes, I would echo that flexibility, which is especially important to biomedical research because of the additional challenges of getting a product into clinical practice. We also strongly encourage the continuation and strengthening of Phase 0 and the administrative support.
Absolutely. I echo that completely. The flexibilities, the option to have a small fraction of the budget for administrative support are the key things that we would recommend.
I agree. I think the flexibility that the agencies have, the ability to continue to expand the phase 0 sorts of pilots and make those more generally available, and to maintain the set-asides at their current levels would be my major recommendations.
Thank you for that. In terms of measuring success or the metrics used to do that under both SBIR and STTR, can you comment a little bit on how you measure success in those two programs?
So as I described earlier, we think of SBIR, STTR as part of a portfolio that connects discovery in the lab, invention in the lab, to the real-world commercialization. So it's a piece of an ecosystem involving Innovation Core program that we talked about earlier in this testimony, as well as many of our research centers, ERCs, IUCRCs, science and technology centers. In terms of success, one has to look at ultimately formation of companies, creation of new technologies, and I really emphasize people. I mean, ultimately, it's people who go through these programs, they become lifelong contributors and inventors and discoverers that will add to the economic competitiveness of the nation. So I would look at people who are changed by these programs.
Thank you.
I would say, in addition to the traditional metrics for biomedical research, we would consider two important factors. One is incorporation into clinical practice. Does it actually benefit real patients in the real world? And then the second is some of our SBIR work goes into developing tools for research that researchers can use to advance science. And we have seen examples where tools have led to advances in knowledge that otherwise could not have happened.
Thanks.
One of the things that we've done in our STEM education, science, technology, engineering, and mathematics workforce development is to set up systems that will track students, participants over a long period of time and enable us to look at outcomes 5, 10, and more years down the road. And I think if you really want to do these kinds of assessments properly, you can't look at short-term outputs. You have to look at the long term. And so those would be my recommendations.
Thanks.
And I think one of the major purposes of the SBIR and STTR programs is to help universities, at least from our perspective, is to help us get the research results, the things that come out of our laboratories, into the marketplace so that the public can benefit from them. So I look at whether or not the technologies that we create and we launch through these companies are actually being used, and are they available to the public.
Thank you. Those are all my questions, Madam Chair. Thank you.
Thank you. And I now recognize Ms. Clark for 5 minutes.
Thank you, Chairwoman Comstock and Ranking Member Lipinski, for this hearing, and thank you to all of our witnesses today. We are delighted to have you, and I think your testimonies have underscored the immense value of the SBIR and STTR in making sure we're taking that research out of the labs and into the private sector. And we're very grateful for being here. Dr. Dehmer, I'd like to go back to a program that you mentioned, which is the Phase 0 Assistance Program. As we see women increasingly, we're up to 30% of women who are owning their own businesses, and it's one of the fastest growing sectors, but we're not where we should be, especially with women of color. And I wondered, as one of the primary focuses of these programs is to encourage participation, women and minority-owned businesses, I wondered if you could go into a little more detail on how the Phase 0 program benefits businesses that may be submitting a proposal for the first time, and how you see the Phase 0 encouraging women and minority-owned businesses.
So there's two parts to that. The first is outreach to women and minority-owned businesses, and we're working hard to increase our outreach through various mechanisms, through physically getting on the road, through webinars and so forth. And the second is enabling people through small investments to be better prepared to write successful SBIR grants for the first time. And I think that's very important. This actually goes beyond just SBIR. This goes to enabling people who have never submitted a research grant to be able to do it successfully. And so our Phase Zero program, there's many different Phase Zero programs, so they're not all the same, but ours specifically provides people with help in navigating the federal system, the application system, and in giving them help in letter of intent writing. If you don't write a good letter of intent for the programs, you're out right away, at least in some of the research programs. How to write a Phase 1 proposal, how it gets reviewed, how you're going to submit it, communication and marketing research, technology advice, and so forth. So what I've personally observed with young people submitting proposals for the research programs, and that applies to first-time applicants to SBIR, is that they will need help navigating the federal system and learning the basics of how to do something successfully. And frequently, they aren't successful just because they don't know.
Do you know how many Phase Zero program participants have been successful in securing SBIR or STTR awards?
Yeah, so it's a new program, and the only thing we know so far is that the success rate for people who've been through the Phase Zero program is about the same as the success rate for others. And at first blush, you might think that that wouldn't be the case because the people submitting for the first time that would be less successful.
Yeah.
But I think it's actually going to take a lot more statistical analysis with control groups and so forth to know for a fact that the Phase Zero program is helping. But we do know that the success rate is about the same for first-time applicants who've been, or for recent applicants who've been through the Phase Zero program compared to those who do not.
Thank you. And Dr. Lauer, the National Academy's 2015 assessment of the SBIR, STTR, NIH found that women and minority participation is, quote, low and declining. Are you aware of any changes or approaches that are being taken at NIH to address this problem?
Congresswoman, yes, we are aware with the finding in the NAS report, and we are quite concerned about that as well. Our SBIR office is engaged in a number of outreach efforts, which I mentioned specifically in my opening testimony. We're also looking, similarly to my colleague here, at how the Phase Zero programs can help, and we'd be happy to follow up with some more details.
Thank you very much. And just very generally, Dr. Khargonekar, have you seen the discrepancy between NSF's overall funding level increases and the SBIR, STTR funding? Has that had an effect on NSF's mission?
I mean, I think what it has done is, since the growth in our basic research budget has not been as strong, it has reduced the amount of funding we have available for funding our core research programs in all areas of science and engineering. And that's the reason why we are saying that let's not increase the set-aside percentages as a way to increase the SBIR, STTR program. Let's grow the entire research budget, which allows SBIR, STTR to grow. So yes, it has had impact.
Yeah, and I agree with you. I think we need to increase the pie, not reallocate the slices. But thank you all. Thank you for your testimony and your work, and I yield back.
Now recognize Mr. Tonko for 5 minutes.
Thank you, Madam Chair. I, for one, am excited that we're holding this hearing today because I very strongly believe that reauthorization of the SBIR STTR program is of the utmost importance. In fact, it should be broadened and extended and enhanced. I so much believe in it. This program has proven to be one of the most successful federal programs for technological innovation in our history, delivering more than 70,000 patents and valuable innovations in agriculture and defense and energy, health sciences, homeland security, space, transportation, and other fields. You can't get better results than that. Through Phase 1 and Phase 2 SBIR, countless jobs have been created in the capital region of New York that I represent. It is through programs such as SBIR that my district has developed the underpinnings of support for a boom in high technology innovation and economic development. I would cite International Electronic Machines Corporation in Troy as a stellar example of all of that. Let me begin with Dr. Lauer. The 2011 reauthorization allows NIH, DoD, and Department of Education to conduct a pilot program to allow a small business to receive a Phase 2 without having received a Phase 1 award, also known as the Direct to Phase 2 pilot. I have some concern that allowing companies to skip Phase 1 I would shut out some small businesses from competing for SBIR award funding. Can you elaborate, Doctor, on direct to Phase 2 funding and efforts to prevent marginalization of some small businesses out there?
Thank you, Congressman. I think part of the reasoning for that is that we have observed that it's rare that a product goes from Phase 0, Phase 1, Phase 2, Phase 2B, and then final approval and marketing. The process in the real world is not that linear. And often there are, for example, 2 Phase 2 awards that ultimately lead to the development of a product. So the idea of direct to Phase 2 was to consider other pathways by which a product may eventually make it.
So there shouldn't be a risk of marginalization?
Well, we certainly don't want that to happen, and that's, I think, gets to the point that a number of your colleagues have made, which is that we have to track metrics very carefully, and that we are doing.
Okay, I appreciate that. The research and development of technologies in the biotech field, the energy sector, as well as other technology areas require large investments of capital in the range of hundreds of thousands, if not to millions of dollars. The 2011 reauthorization provides increased flexibility to agencies in the amount of funding they award to small businesses under SBIR. Additionally, I'm informed that the timeline for innovation does not necessarily fit neatly into the Phase 1, Phase 2, and Phase 3 approach used by our SBIR program. The last reauthorization also allows agencies more flexibility to structure the funding award at their discretion. So I would ask each of our witnesses, how have each of your agencies or sections, your divisions, implemented these new flexibilities?
As I mentioned earlier in this testimony, we certainly have used the flexibility. For example, we have increased the Phase 1 award size. We have increased the duration of Phase 1. We have increased the Phase 2 and Phase 2B sizes. We have used Phase 2B to attract more private sector funding through the 2-to-1 match requirement. So if you want to get Phase 2B funding from NSF, private sector has to come in with a 2-to-1, at twice the amount that NSF would provide. So we certainly have used the flexibilities that have been afforded to us to increase the overall impact of taking discovery and invention and commercializing it to the real world.
Thank you, Dr. Khargonekar. And Dr. Lauer?
So at NIH, 2 examples would be the Phase 2B awards as well as the Bridge Awards, which the National Cancer Institute has implemented. And these awards enable up to 3 years of funding, $1 million a year. And this is particularly important when you're trying to move a product into clinical trials.
Thank you. And Dr. Dehmer?
Yeah, I think you've heard a lot of examples from me in DOE and from my colleagues. I think the bottom line here is that increased flexibility enables an agency to do experiments that are targeted at the kinds of small businesses that the agency wants to develop. And without that flexibility that allows experiments, you simply are going to be locked into a structure which may not fit everyone. I've observed in my own research career and in my management career at DOE, watching several groups of the same kind that are funded at very different places evolve in different ways because we allow them the freedom to evolve. And what you find are best practices and innovation, and that then can be ported from one group to another. So the flexibility to allow experimentation is extremely critical in this program. And the 2011 authorization, which provided that, was terrific.
Thank you. And Ms. Garton?
The flexibility that the agencies are using helps our companies. The companies that we create follow a nonlinear path, as somebody just said. It really is variable across the sector and across the technology development pathway because things come up in the development of those technologies. And having that flexibility to have a second Phase 2, to have bridge funding, that's really critical for those companies because that gives them flexibility.
Well, I think harnessing the intellect of this nation in the midst of an innovation economy is an awesome assignment. You're doing that and doing it very well. And with that, Madam Chair, I yield back.
Thank you. And I'd like to thank the witnesses today and thank you for your passion, for your important work, and the importance of basic research and our role in that. And I really appreciate your support for the innovation economy and how we're going to do that. And I did note that we have a number of students here. Are these students that we have? If you're a student, raise your hand back out there. Great. Well, good. Well, it's been very nice to have students here, and I hope you appreciate all the good work that's going on here and see a lot of the support. And if you're science students and STEM students in any of those fields, we are definitely interested in making sure you stay in those fields. We need you in those fields, and these are the leaders that you'll want to be watching over the years and hopefully joining. So thank you, students, for being here today. And again, thank our witnesses for all they do in this very innovative and exciting field. And we are now adjourned. Thank you. Sorry I ran in here late. Oh, thank you. Thank you.
Thank you.